fluid mechanics, electromagnetism, and solid mechanics. With this in mind, it is easy to imagine that there can be a large number of multiphysics combinations. The equations that express the laws of physics have to be solved numerically in most practical cases. For example, the laws of magnetostatics formulated for the complex geometry of a magnetic elevation train results in a system of partial differential equations in space and time. Such a system can be solved using the finite element method. The characteristics of the solution can help you gain an understanding of the equations and phenomena they describe. In this case, the shape and strength of magnetic fields. When an optimization of the operation of the train is to be done, the laws of magnetostatics have to be coupled to the laws that describe the displacement of the train, which are the Newton laws of motion. The model of the train is called a multiphysics model. Multiphysics modeling accelerates the understanding of a studied process or phenomenon. This also leads to improved design and operation within a given time frame. Multiphysics modeling and the understanding of multiphysics phenomena is one of the most important issues in scientific and technological development.
Exactly. So that's it about that. It gives you an overview of the multiphysics and the incorporation of all physics laws into a design that you want to model. Then I'm going to take you in a while through
Wrong mouse. The wrong mouse. Hey, that's the wrong mouse.
is it? Oh, oops. Thank you. Well, so this is the desktop layout of forms of multiphysics, and it looks just fine, and it's good to understand. It's not really complicated. And the first thing that you do is define your dimension. Select the dimension from this mode. You choose a 3D or either of these, and then this button tells you to go on. We will not do that because we are not trying to create a model. Right here is the file edit option as help. We have the model builder, and we have the global definition where you define the parameters and variables of your model, and then you generate your results right here. I'm gonna try to this file, that icon, and then come to the open model library. So we have all these model library. I just picked but a few. I picked the batteries and fuel cells. I picked the chemical engineering, so you can see all the rest. If you open up the battery and fuel cell, you can find the proton exchange membrane fuel cell. That could be part of what we might be working for. And look at the high temperature proton exchange membrane. And if you come just down, you'll see the diagram, the model, the graphics of the cell stack. If you hit the open, this diagram will be shifted here in the graphics. So we'll be able to now work on that. Then we'll go into the global definitions and pick the variables that we want to work on, the dimensions. And then we'll go into the material library right here select the material that you want for that particular object, and we could choose the metals that we want to pick, generate for the model. If you want to use copper, you want to use the element, a certain element. If you choose the alloys, we go ahead and do and fix them. Then the calculation and the simulation will now depend within the physics of the particular inbuilt equation for the particular material that we pick. If it's easier to scroll this down to see all the others, maybe it goes down. It's not an easy mouse. You see the properties of the model that you pick, the functions and all the other inputs, any other information that you would want to generate. I'll come back here into the options. We have the material browser. We have the model library update. If you want to put in extra information from without the software, if you want to import some information from a different software, then you can be able to update that and fix it in the COMSO software. And then we want to generate a different kind of layout. But one more thing that I want to talk about is about the library, the help library. If you hit help material, it gives you all you need for that particular model or particular process that you want to generate. So my feeling about this software is that it's not so bad to use this software and try the much that we can to simulate a certain process that you want to generate in either chemical engineering or any other engineering field. Right now, I'm still working with my coordinator, Dr. Jim Henry. He is going to coordinate on how the university can acquire this software and see if it could be of much use in the department, and it would really help us create everything that we need. That's all I have